This video is on making, naming, and drawing esters. So first of all, we have to talk about what an ester is. An ester is an organic compound that has this characteristic elements and bonds in it. You need a carbon double bonded to an oxygen and a carbon single bonded to an oxygen. And this cannot be an H, because if this here is an H, that makes it a carboxylic acid. So we have to have carbons going this way and a hydrogen or carbons going this way. And this R1 represents various amounts of carbons. So you could have 1 or 2 or 3. And this can also be 1, 2, or 3, or even an H on this side. So that's what an ester looks like. And here's an example without the use of R's. So here's an example of an ester. And I can see the characteristic C double bond O, and notice this is not an H here, so it's not a carboxylic acid. So this is an ester. So how was this ester made? Well, it's similarly made to what we did in class. We reacted carboxylic acids with different alcohols, and we made some of those fragrant esters that we smelled in class. So for example, here I have butanoic acid reacting with ethanol. When they react, the H from the butanoic acid, or the H from the carboxylic acid, bonds with the OH of the alcohol to make water, and the remaining parts of the two molecules bond together. So I need to take off, so I'm going to use my little eraser here, this H and this OH. And HOH makes water. So I get water as one of my products. And then this oxygen now needs another partner. It needs another bond. Where does it bond? It bonds to the carbon from the alcohol. So here we have butanoic acid reacting with ethanol. But we can't call it butanoic acid ethanol anymore. So what do we call it? Well, we have two names put together that represent both the acid that it came from and the alcohol that it came from. And the rule is to name the alcohol side first. So because there were two carbons, we still use Eth to represent the two carbons that came from the alcohol. But since it's not, ethanol. Sorry about that spelling there. Let me erase that. There, we got it. So ethanol. So it's not an alcohol anymore, so we don't call it ethanol. We use eth for the two, but now it has a different ending. We say YL. So this is ethyl. So that represents this part of the molecule. The other part of the molecule has 4 carbons, 1, 2, 3, 4 for the bute. So we still have the bute part. It still has single bonds between them, so we have the AN part. But it's not an acid anymore, so the ending for esters is OATE. So this ester would be called ethyl butanoate. So what happens if I have an ester already drawn and I want to name it without seeing the acid and the alcohol? So here's an ester. I can tell because this is the characteristic part, the C double bond O to and a C to an O. So now I have to name it, and the alcohol side comes first and the carboxylic side comes second, but which side is which? Well, the alcohol side is the one next to the single bond O, and the carboxylic acid side is the one next to the double bond O. So I named this side first. I have 1 carbon on this side, so that prefix is meth, and it has an ending here of YL, meaning a single carbon group, methyl group. And then I named this side of the molecule 1, 2, 3, and yes, you count this carbon that is attached to the double bond O. So 1, 2, 3 carbons is prop. It still has single bonds here, so I still say AN, but I give it the ending OATE. So this ester is methyl propanoate. What happens if you're given a name and you have to draw it? Well, I look at this name and I see OATE at the ending, so I know it's an ester. So somewhere in the molecule, I have to have the C double bond to the O and the C also single bonded to the O. The first part comes from the alcohol side, which is next to the single bond O, and it says pentyl. So pent meaning 5, so I must have 5 carbons next to that O. 1, 2, 3, 4, 5, and I can add the hydrogens. And the carboxylic acid side had 6 carbons. I know that from the hex. So this counts 1, 2, 3, 4, 5, 6 carbons. Oops, it doesn't like, maybe I'll have to bend it to the side. Sorry about that. And then we can add the hydrogens. So this is pentyl hexanoate. So there we have it, a little lesson on esters, how they're named, how they're written, and how they're made. So give it a try with the esters from the lab today. Good luck.